Welcome to online learning. This presentation is for class 10th, subject maths, chapter 4, linear inequations. An inequation is formed when two mathematical statements have an inequality sign between them. Common inequality signs are is greater than or equal to, is less than or equal to. Inequations can have an infinite number of solutions. Examples of inequations are 2x minus 5 less than 1 or 3 minus 5x greater than 18. If a, b and c are real numbers, then each of the following is called a linear inequation in one variable. Ax plus by is greater than c, ax plus b less than c, ax plus b is greater than or equal to c, ax plus b is less than or equal to c. In an inequation, the signs greater than or equal to, and less than or equal to are called the signs of inequality. For solving linear inequations, we have to follow certain rules. So let us learn about them. Rule number 1. On transferring a positive term from one side of an inequation to its other side, the sign of the term becomes negative. For example, 2x plus 3 is greater than 7. When we shift this plus 3 towards right hand side, it will become minus 3. So we get 2x greater than 7 minus 3. 5x plus 4 less than or equal to 15. Then plus 4 we need to shift on the right hand side, so it will become negative. So we will get 5x less than or equal to 15 minus 4. In the same way, if we have 23 greater than or equal to 4x plus 15, we will get 23 minus 15 greater than or equal to 4x. What we have done, we have just shifted this plus 15 to left hand side. The rule is same as we follow to solve simple equations. Rule number 2. On transferring a negative term from one side of an inequation to its other side, the sign of the term becomes positive. For example, 2x minus 3 is greater than 7 is given. So we need to shift this minus 3 towards right hand side. So this minus 3 will change to plus 3. In the same manner, 5x minus 4 less than or equal to 15, we will get 5x less than or equal to 15 plus 4. On shifting this minus 4 towards right hand side, it will become positive. 23 greater than or equal to 4x minus 15, we need to shift this minus 15 to LHS, so its sign will change to positive. So we will get 23 plus 15 greater than or equal to 4x and so on. Next rule is, if each term of an inequation be multiplied or divided by the same positive number, the sign of inequality remains the same. For example, if p is positive and we have x is less than y, so on multiplying both sides by p, which is a positive number, there will be no effect on the inequality sign, as here is less than. After multiplying both sides by p, we will get the sign less than only. If we divide it by a positive number p on both sides, then also there will be no effect on the inequality sign. So we will get x upon p less than y upon p. If we have x is greater than y, then again if we are multiplying both sides by a positive number p, the inequality sign remains same. So we will get Px greater than Py, and on dividing both sides by P, we will get x upon P is greater than y upon P. In the same manner, if we have x is less than or equal to y, on multiplying or dividing both sides by positive number P, we will get Px less than or equal to Py, and x upon P is less than or equal to y upon P. And if we have x is greater than or equal to y, then on multiplying both sides by positive number P, we will get Px greater than or equal to Py, and on dividing both sides by P, we will get x upon P greater than or equal to y upon P. Examples are, when we have x is less than or equal to 6, then on multiplying both sides by 4, we will get 4x less than or equal to 4 multiply 6. In the same manner, x is greater than or equal to 5, then 3x is greater than or equal to 3 into 5. That means we have multiplied both sides by 3. So no effect will be there on the inequality sign. Earlier also it was greater than or equal to. Now also it is greater than or equal to. If we have x is less than or equal to 2, on dividing both sides by a positive number 10, we will get x upon 10 is less than or equal to 2 by 10. Rule 4. If each term of an inequation be multiplied or divided by the same negative number, the sign of inequality reverses. That means greater than will change to less than, or less than will change to greater than. For example, if P is negative, then we have x is less than y. So on multiplying both sides by a negative number P, we will get Px is greater than Py. What is there? Initially we were having less than sign, but after multiplying by negative number on both sides, we get greater than sign. So inequality sign reverses. In the same manner, here we are dividing both sides by a negative number P. So inequality sign less than will change to greater than. So we will get x upon P is greater than y upon P. If we have x is greater than or equal to y, then on multiplying both sides by negative number P, we will get Px is less than or equal to Py. And on dividing both sides by P, which is a negative number, we will get x upon P is less than or equal to y upon P. This less than or equal to is reverse of greater than or equal to. Examples, x is less than or equal to 6. So on multiplying both sides by negative number, that is minus 4, we will get minus 4x. This less than or equal to will change to greater than or equal to. So minus 4x greater than or equal to minus 4 into 6. If we have x is greater than 5, then minus 3x is less than minus 3 into 5. That we obtain by multiplying both sides by minus 3. When x is greater than or equal to y, we will get x upon minus 2 is less than or equal to y upon minus 2. Since we have divided by a negative number minus 2 on both sides, so this inequality sign will reverse. So here greater than or equal to will change to less than or equal to. Rule number 5. If sign of each term on both the sides of an inequation is changed, that means positive terms are changed to negative or negative terms are changed to positive, the sign of inequality gets reversed. For example, if we have minus x greater than 5, since minus x is negative and 5 is positive, now what we are doing, we are changing their sign. So minus x is becoming positive and 5 is becoming negative. So the inequality sign will reverse. So we will get x is less than minus 5. If we have 3y less than or equal to 15, on changing the sign on both sides, we get minus 3y greater than or equal to minus 15. This is the reverse of the initial inequality sign. Minus 2y less than minus 7. So if we change both the terms to positive, then again the sign of inequality will reverse. So here we have less than, so here it will be greater than. So we will get 2y is greater than 7 and so on. Rule number 6, if both the sides of an inequation are positive or both are negative, then on taking their reciprocals, the sign of inequality reverses. If x and y both are either positive or both are negative, then if x is greater than y inequality we have, then on taking the reciprocals on both sides, we will get 1 upon x is less than 1 upon y. And here, x is less than or equal to y. On taking reciprocals on both sides, we will get 1 upon x greater than or equal to 1 upon y. This less than or equal to sign will change to greater than or equal to. Again, if we have x is greater than or equal to y, on taking their reciprocals, we will get 1 upon x is less than or equal to 1 upon y. So, on taking reciprocals on both sides, again the inequality sign reverses. To solve questions based on inequations, we should understand first about real number system. We know that real number system is classified as two sets. They are the set of rational numbers and a set of irrational numbers. Together they constitute the real number set. So among the rational numbers, we have integers, whole numbers and natural numbers. And rational numbers are those which can be represented in the form a upon b, where b is not equal to 0. And integers constitute all positive and negative numbers including 0. 0, if we say 0 is non-positive, non-negative integer. So all the positive integer and negative integers, positive numbers, negative numbers including 0 comes under the set of integers and it is denoted by capital Z. W stands for set of whole numbers which include all the numbers starting from 0, 1, 2, 3, 4 and so on up to infinity. Natural number set starts from 1, 2, 3, 4 and so on up to infinity and it is denoted by capital letter N. If we talk about irrational numbers, then irrational numbers are root form numbers, the numbers in the form of root, for example root 2, root 3, which are not a perfect square. If we take cubes, then they should not be perfect cubes. And pi, these are irrational numbers. Let us know about replacement set and solution set. The set from which the value of the variable x is to be chosen is called the replacement set, and its subset whose elements satisfy the given inequation is called the solution set. So solution set is a part of replacement set. Let us take an example. Let the given inequation be x is less than 3. If the replacement set is n, n stands for the set of natural numbers. So the solution set will contain the elements 1 and 2. Since natural number set starts from 1 to infinity, so the inequation is x is less than 3. So all the natural numbers which are less than 3 will be included in the solution set. So here we will get the solution set as 1 and 2. If the replacement set is W, that is the set of whole numbers, and we know whole number starts from 0 up to infinity. So solution set will contain all the whole numbers which are less than 3. So the elements of the solution sets will be 0, 1, 2. If the replacement set is Z or I, which stands for the set of integers, so the solution set will be containing all the integers which are less than 3. So less than 3 if we say, then we will have 2, 1, 0, minus 1, minus 2, minus 3 and so on up to infinity. So if the set is going up to infinite terms, so we are required to show by drawing the dots. But if the replacement set is the set of real numbers, the solution set can only be described in set builder form, that is x where x belongs to real number and x is less than 3. The same condition, that is the inequation, we will write in the set builder form along with the condition that x belongs to real number. So for the whole number, natural number or integers, we can represent the solution set in the form of tabular form because we have the distinct terms there, distinct number there. But for replacement, if the replacement set is the set of real numbers, then it should be written in the form of set builder form. After getting the solution set, we are required to plot these numbers or solutions on the number line. So when we draw a number line, on the left hand side we have negative numbers and on the right hand side we have positive numbers, and in between we have 0. 0 is considered as non-positive, non-negative integer. So all these positive numbers, negative numbers, including 0, constitute the set of integers. And the numbers starting from 0 to infinity towards positive direction includes whole numbers. And starting from 1 to infinity on the positive direction, we have natural numbers. And what about real numbers? All the numbers containing these integers, whole numbers, natural numbers, and even the numbers between two consecutive numbers. For example, here 2 and 3 if we consider, in between 2 and 3 there are infinite numbers like 2.1, 2.3, 2.7 and so on, and even the numbers up to 2 decimal places like 2.12, 2.25, 2.37 and so on. That means there are infinite numbers between two consecutive natural numbers, whole numbers or integers. So these numbers are included in the set of real numbers. So students, representation of whole number, natural number and integers on the number line you know very well, but representation of the solution on the number line when x belongs to real number is quite different from that. So let us learn that. For example, if we have the solution x is greater than 5, then we need to check whether 5 is included or not. So here all the values which are less than 5 are included, but 5 is not included. So on 5 we will make a hollow circle and all the numbers which are greater than 5 will be on the right hand side of 5 on the number line. So towards positive direction, starting from 5 we will make a continuous line. This shows that 5 is not included, but after 5, 5.1, 5.2, 5.3 and so on up to 6, then 6.3, 6.7 and so on. In between these numbers also the numbers are included. Second example is x is less than -1. So again we will see whether -1 is included or not. So here all the values which are less than -1 are the solution. So we will make -1 as hollow circle because -1 is not included. And all the values which are less than -1 will be on the left hand side of -1 on the number line. So towards left hand side, we will draw this line. When x is greater than or equal to 3, now 3 is also included as we have equal to sign in between. So on 3, we will make dark circle which shows that 3 is also included. And the line towards positive direction means all the numbers which are greater than 3 are the solutions, like 3.1, 3.2 and so on, then 4, then 4.1 and so on. That means 4, 5, 6, 7, 8, 9 and so on up to infinity. And all those infinite numbers which lie between two consecutive numbers are also included in the solution. When we have x is less than or equal to 5, again 5 is included as we have equal to sign here. So since 5 is included, so on 5 we will make a dark circle, and all the numbers which are less than 5 are also included. So being real number set, we will make a continuous line towards left hand side, that means towards all the numbers which are less than 5. Let us have some examples. Solve and graph the inequation 3 minus 2x greater than or equal to x minus 12, given that in first part x belongs to natural number, second x belongs to whole number, third x belongs to integer, and fourth x belongs to real number. So we will discuss all these cases. First, let us have the equation, that is 3 minus 2x greater than or equal to x minus 12. So for finding the solution, we need to shift all x terms, that is variable terms, towards LHS and simple terms towards RHS. So here minus 2x we will take here itself, and from right hand side we are going to shift this x towards left hand side, so it will become negative from positive. And minus 12 is still there on the right hand side, and from left hand side we are going to shift this 3. Since 3 is positive, so when it will come on the right hand side, it will become negative. So on solving this, we will get minus 3x greater than or equal to minus 15. Since we need the value of x, so we need to make both the terms as positive, or this minus 3x as positive. So we need to change the sign on both sides, and as we have learned in the rules that when we are changing the sign on both the sides, then the sign of inequality reverses. So here minus 3x is becoming positive, minus 15 is also becoming positive, so this inequality sign will reverse. Since here we have greater than or equal to, so on changing the sign it will become less than or equal to. So now we will get x is less than or equal to 5. How? By shifting this 3 towards RHS. Then we will get x less than or equal to 15 by 3, which will give x is less than or equal to 5. Now let us consider first case where x belongs to natural number. Since x belongs to natural number, and we know natural number starts from 1 to infinity. So solution set will have the elements all the natural numbers which are less than or equal to 5. That means 5 is also included. So we will get the solution set as 1, 2, 3, 4, 5, where 1, 2, 3, 4 are less than 5 and 5 is equal to 5. So now how can we represent it on a number line? On the number line, we will make these divisions and mark the numbers as -1, 0, 1, 2, 3, 4, 5, 6 and so on, and make sure that before this 1 and after this 5 you are making 1 or 2 divisions extra. That means whatever solutions you need to show on the number line, on both the sides you should take 2 extra divisions or at least 1 extra division. So here when we draw this number line, we have the distinct solutions there like 1, 2, 3, 4, 5. So we will make the dark circles on the number 1, 2, 3, 4 and 5. Second case is when x belongs to whole number. Since whole number starts from 0, 1, 2, 3 and up to infinity. So according to the solution, x is less than or equal to 5 means all the numbers, all the whole numbers which are less than 5 and equal to 5 will be included. So we will get the solution set as 0, 1, 2, 3, 4 and 5. So again, for representing it on the number line, we will draw a number line, and as I told you before, the first solution and the last solution, you need one extra division at least. So we will take -1, 0, 1, 2, 3, 4, 5, 6 and 7 and so on, and we will make the dark circles or dark points on these numbers as 0, 1, 2, 3, 4, 5. Third part is when x belongs to integers. Now, as we know, integers contain all positive numbers, negative numbers, including 0. Since we have the solution as x is less than or equal to 5, so all the integers which are less than 5 and the integer 5 will be in the solution. So we will have 5 which is included, and less than 5, all the integers will be 4, 3, 2, 1, 0, then -1, -2, -3 and so on up to infinity. As we go towards left hand side on the number line, all those negative integers will be less than 5. So on the number line, we will locate these points by drawing the dark circles there as 5, 4, 3, 2, 1, 0, -1, -2. Now, since we cannot draw the line up to infinity, so on the line after this -2, we will show these dots. Dot, dot, dot. It stands for, it shows that the solutions or all the numbers before this -2 towards left hand side are also included. Now the case 4 is when x belongs to real number. So solution set on the real number, as I told you, that we cannot represent it in the tabular form because the numbers between two consecutive natural numbers or whole numbers are also real number, which are in the form of decimal. So if x belongs to real number, then we need to specify its solution set in the form of set builder form. So we will write the solution set is equal to x, where x belongs to real number and the same condition of the solution, that is x is less than or equal to 5. So now when we draw its number line, again we need 5 there, 5 is included, and all the numbers which are less than 5 are also included. So here we are not going to make dark circles on the different points or different number positions. Why? Because the numbers which are in between these two consecutive numbers are also included in the set of real numbers. So here all the values which are less than 5 will be on the left hand side of 5 on the number line up to infinity. So on 5 we will make a dark circle since it is included, and towards the right hand side we will make a line up to infinity. Some more examples. For the following inequations, graph the solution set on the real number line. First part, -4 less than or equal to 3x minus 1 less than 8. Since it is containing 3 parts, so we will break it into separate 2 inequations by taking first part and second part, and then by taking second part and third part. So we will get -4 less than or equal to 3x minus 1 from first and second term, and 3x minus 1 less than 8 from second term and third term. So solving this, we will get minus 1 less than or equal to x, and solving second inequation, we will get x is less than 3. Now we need to make the solution set. Since this replacement set is given as real number set, so the solution set will be written in the form of set builder form. So we will write x where x belongs to real number, minus 1 less than or equal to x greater than 3. These two conditions we have joined from here. So minus 1 less than or equal to x and x is less than 3. So we will get the condition minus 1 less than or equal to x less than 3. Now we need to represent this solution set on the number line. Since we have minus 1 and 3, so on both the sides we will show some extra divisions. Now on the number line we will check whether minus 1 is included. Yes, it is included because here equal to sign is there. So on minus 1 we will make a dark circle, while on 3 we will make a hollow circle because 3 is not included. But the numbers between minus 1 and 3 all are included. So starting from minus 1 and 3 we will draw a dark line which shows that all these numbers minus 1 and 1 minus 1.5 and so on, and all these numbers but less than 3 are included in the solution. Second part is x minus 1 less than 3 minus x less than or equal to 5. Again we have 3 terms, so we will divide it into 2 by taking first term and second term and forming an inequation x minus 1 less than 3 minus x and 3 minus x less than or equal to 5 by taking second and third term. Solving first set of inequation, we will get 2x less than 4 where x is less than 2, and solving second set we will get minus x less than or equal to 2. On changing the sign on both sides, the inequality sign will reverse. So we will get x is greater than or equal to minus 2. Now solution set. Again, the replacement set is set of real numbers. So we will take the set builder form. X where x belongs to real number and minus 2 less than or equal to x which is less than 2. Now to represent it on the number line, we will draw the number line and make divisions there and then check minus 2 is included or not. Yes, it is included. So on minus 2 we will make a dark circle, and 2 is not included since here we don't have equal to sign. So the numbers which are less than 2 are included, but 2 is not included. So on 2 we will make a hollow circle. Then the numbers between minus 2 and 2 are also included. So starting from minus 2 and 2 up to 2, we will make a dark line. Next example, x belongs to real numbers and minus 1 less than 3 minus 2x which is less than or equal to 7. Evaluate x and represent it on a number line. So by taking the inequation minus 1 less than 3 minus 2x less than or equal to 7, again divide it into 2 by taking first term and second term and third term. Solving first set we will get 2x less than 4 which will give x is less than 2, and second set will give minus 2x less than or equal to 4. By shifting this 3 this side we will get 7 minus 3, that is 4. Now we need the value of x, so we will make this 2x as positive. So on changing the sign on both sides, the inequality sign will reverse. So 2x greater than or equal to minus 4 which will give x is greater than or equal to minus 2. So now two conditions we have got. So joining them, we will get the solution set in set builder form because x belongs to real number. So solution set will be x where -2 less than or equal to x greater than 2 where x belongs to real number. Thus, the solution can be represented on a number line as, we will draw the number line and now we will check whether -2 is included. So here, yes, -2 is included because equal to sign is given. So here we will make a dark sign, dark circle, and on 2 we will make hollow circle because 2 is not included. And the number between -2 and 2 are included, so we will make a dark line here. Example 4. Find the values of x which satisfy the inequation given, where x belongs to natural number. Graph the solution on the number line. So let us take the given inequation. -2 less than or equal to 1 by 2 minus 2x by 3, which is less than or equal to 1 whole 5 by 6. Now, if we see the middle term, we have 1 by 2 minus 2x by 3 and we need to evaluate the value of x. So, 2x by 3 is the required term. 1 by 2 we need to remove. And since here 1 by 2 is positive, so from all three sides we will subtract 1 by 2. So we will get -2 minus 1 by 2. And from the middle term, 1 by 2 minus 2x by 3 minus 1 by 2 less than or equal to 11 by 6. From here, 6 ones are 6 plus 5, 11 by 6 minus 1 by 2, which will give three terms as -5 by 2 less than or equal to minus 2x by 3, since -1 by 2 and -1 by 2 will get cancelled. This positive 1 by 2 and -1 by 2 will get cancelled, and what is left? -2x by 3, which is less than or equal to 8 by 6. Now we can split these three terms in two inequations by taking first term and second term and third term. So here we get -5 by 2 less than or equal to -2x by 3, and second set of inequation will be -2x by 3 less than or equal to 8 by 6. On solving this, on cross multiplication, we will get -15 less than or equal to -4x. Since we need the value of x, so we will make it positive. So on changing the sign on both sides, the inequality sign will reverse. So we will get 15 greater than or equal to 4x, which will give 15 by 4 greater than or equal to x, or 3.75 greater than or equal to x. Or we can write it as x is less than or equal to 3.75. From second set we will get, on cross multiplication, -2x less than or equal to 4, and on further cancellation, 2x greater than or equal to -4. So x is greater than or equal to -2. So we will get two conditions here. 3.75 is greater than or equal to x, and x is greater than or equal to -2. So let us form the solution set. The solution set will be x belongs to natural number, and from these two solutions we will make this condition -2 less than or equal to x, which is less than or equal to 3.75. Since it belongs to natural number, and we know natural number starts from 1, 2, 3 and so on up to infinity. So -2 will not be included, -1 is not a natural number, 0 is also not a natural number. So the natural number solutions according to this will start from 1, 2, now 3 will come, but since here is written x is less than or equal to 3.75. So less than 3.75, the natural number is 3, closest to this 3.75. But 3.75 is not a natural number, therefore we will not take this value. So the required elements of the solution set will be 1, 2 and 3. Now let us represent them on the number line. We will draw the number line and represent the natural numbers 1, 2 and 3 by making the dark circles on their exact positions. Example 5. Find the smallest value of x for which 5 minus 2x less than 5 whole 1 by 2 minus 5 by 3x, where x is an integer. So let us take the inequation 5 minus 2x less than 5 whole 1 by 2 minus 5 by 3x. Minus 2x plus 5 by 3 into x, we have shifted this 5 by 3 x term towards LHS. Then its sign changed from negative to positive. Less than 11 by 2 minus 5. This minus 5 comes as we shift this 5, positive 5 towards RHS. On solving, we will get minus x by 3 less than 1 by 2. On cross multiplication, minus x less than 3 by 2. Since we need the value of x, so we will change the sign on both sides, and on changing the sign on both sides, the inequality sign will reverse. So x will become greater than minus 3 by 2, which will give x greater than minus 1.5. Here the question is, we need to give the smallest value of x, where x is an integer. X is greater than minus 1.5. So minus 1.5 is not an integer. After minus 1.5, greater than minus 1.5 will be minus 1. So the required smallest value of x is minus 1. Based on the examples discussed, I'm giving you some assignment work. So here are some questions. You can solve them for your practice. Thank you, children. Stay home, stay safe, but study well. Looking forward to see you in the school.